Welcome back to Talking PLM 4.0. I'm Andrew Sparrow.
And I'm Bryan Spellman. It's hard to think of any more disrupted sector over the last few years. Highly personalized products, smarter and smarter devices, COVID disruption to the world's factories, Industry 4.0 technologies from AI to IoT, robotics to big data.
There is no room for complacency, no room to just keep doing what you have always done. Dump, please, that it's the way we've always done it, and dump the if it ain't broke, don't fix it attitude, because the time it takes you to even say that, there's another startup starting up, determined to grab your legacy approach to the market and take you down and take your market share.
That sounds like a lot of tongue twisters, but today we're going to bring in one of our many DS friends to talk about digital transformation in manufacturing and CPG.
We welcome David Szczepanski, a multi-year CPG manufacturing veteran. Ready, set, go. There he is, David. Did I get your last name right? Did I pronounce it correctly?
You did, Andrew. Thank you.
Perfect. Where's that come from, by the way?
Pardon?
Where's that come from originally?
It's Polish.
Figured it would be. Good, good. Home of the hard workers over there. Good. So how's it going? Where are you living these days?
Georgia.
Good. Down in the south. Love it.
It's a far cry from Poland.
Yes.
Definitely. Good.
Yeah.
So let's get things.
Yeah, I'm sorry.
I was going to say, well, let's get things going. Everyone, please, you got a little comment section at the side of this video. Please ask questions, give us your thoughts, and we will try to pick those up as we go through the show. So let's get things started. First up, David, we're talking digital transformation in manufacturing in CPG, which is your long-standing history. I know we didn't give you a massive intro this time around, but you've been on the show previously. Let's start off at a macro level, if I may. What is digital transformation?
Well, in its most basic form, it's the adoption of digital technology by an organization. So a lot of people think it has something to do with IoT or big data or all the newer technologies, but it could be anything that's digital, meaning an MES MOM, warehousing management system, PLM, ERP, anything that is digital or electronic that's used for an organization, and the typical goals are to improve efficiency, value, and innovation. That's it. I mean, again, that's the short definition.
Gotcha. The lasting memory I have was when Industry 4 technologies were coming into the market a few years back and going into a conference. I'll never forget, you'd have these guys with a widget and they were digital transformation, etc.
Right.
It's much more than that, as we well know. What is the breadth of digital transformation in manufacturing in terms of the technologies and the impact that they're having?
Well, I think it varies for one, because just like any newer technologies or concept, it takes a while for people to get going. But it's really down to, and I'm trying to remember if you had mentioned it this time, but it impacts again, efficiency, value, and innovation of products. So there's a lot of personalization going on now within product design. There's a lot of people trying to automate facilities more, so robotics, automation, manufacturing efficiency, productivity improvements, customer satisfaction, engagement. So all these things are impacted by DX in manufacturing. Again, because if you look at the root definition, it's all about efficiency, value, and innovation.
Are these all just inside of manufacturing, or is this across the entire enterprise?
No, I mean, we're focusing on manufacturing, right? But I mean, as far as I know, as far as I'm concerned, it could be anything where you're using, digital technologies within an organization. So that could
Okay.
be anything across the, enterprise, not
So where
just
does that,
not just in manufacturing.
right, and with that, like, where does the data collection start, and how do we really start going about this?
Well, so first people think about when, or at least I did, is when you talk, digital transformation. You start, first thing that pops in people's mind is IoT devices having to add data, to dumb machinery. When I say dumb machinery, machines that are not controlled, or the controllers are proprietary and you can't get to the data. So having to go out and add if I can say it, IoT devices, and you know that's one thing. But there's also the data that is typically collected in manufacturing, but maybe not used effectively. And that could be from execution systems, from quality systems, from process, and like I said, mentioned earlier, warehousing, environmental, raw materials,
Yeah.
COAs, uh, anything that relates back to the manufacturing.
Got it.
And it's not just IIoT is what I guess what I'm trying to
You
say.
bet. You bet. And you talked about a lot of kind of manufacturing operations areas, warehousing, quality, etc., and then obviously in the enterprise. How hard is the integration piece, and what are we doing to enable that?
Well, there's a lot of data out there,
Yeah.
so you have to have someone who knows the data. Everybody thinks about the technical aspects of capturing the data and contextualizing it, but it's actually you have to have the people there, the resources to be able to understand the data, be able to cleanse data. Okay, so and then manage the data. So it's not just the technicalities of it, but quite honestly, we're already collecting a lot of this data already, right? It's just turning that data into information is
Mm.
where I think the next step in the evolution is. That's been the promise over years and years and years, is having to you know turn all these terabytes of data that companies collect and turn it into information that you can act upon.
Yep.
I don't know if I answered your question, but that was my take.
I think so, and it kind of leans into the whole digital twin thing that we hear a lot about these days as well, I guess.
Yeah. So, you know, I don't know if we want to talk about the differences in digital twin and virtual twin. We
We're
can
definitely
certainly
going to
do
go
that.
there. We're definitely going to
Okay.
go there. Yeah, yeah.
Okay.
I mean,
Okay.
I know in terms of that data going into the virtual twin can help
Right.
minimize those negative effects
Right.
by assisting the business.
Yeah. And again, yeah, correct. It's, especially with the virtual twin, and that's one of the big benefits of it. Once you have it, set up, configured, the data is being captured, it's going into the model. You can actually, it's simulating real time, and that's a tremendous advantage. So you're seeing something, you're not waiting until the end of a shift or end of a run or whatever. You can actually see something that's happening right now. Okay, you can feed it in the virtual twin. You can feed in an adjustment to see if that corrects the problem that you're starting to see. It's a tremendous, tremendous, tremendous capability. I'm actually getting goosebumps here.
What about the security aspect of it?
Uh, you mean as far as the data?
Yeah, yeah.
Uh, so yeah, I mean you want to secure the data, make sure the data is secure.
Mm.
But you also there's a trade-off between sharing the data between different organizations, both internally and externally. You just have to be, I guess, data aware of what you're sharing, right? And you have to set up, just like, anything else, you have to set up levels of security,
Yep.
and to be able to allow different organizations, like I said, both internally and externally to the company, to be able to get at the data.
Right.
Because
Right.
that is one of the big benefits, actually being able to share data with some of your suppliers and your customers.
Mm, mm. One of the things I've seen has been a general, not so much in the US, but I think some other parts of the world, there's been a general complacency, a general lethargy to adopt a lot of these new technologies. And I think that's the danger. I recall kind of first entering manufacturing, we would hear about, and you don't worry about digital transformation. You can buy a device here for $1,000 on the line, and you're good to go with your digital transformation. I think we've just got to move people beyond that very basic level now and get them really thinking more holistically. I don't know if that's something you've been saying.
Well, it is, and I think people are, it's the old people, process, technology, right? Everybody thinks that when they first heard about DX, they started thinking, technology, right? But like I said, I think a few minutes ago, you need people, you need
Yeah.
process, right, to make it work.
Yep. Got it.
So all the technologies that we're seeing these days, what are you seeing as making the greatest impact?
There are a lot of them. I'm sitting here,
Listing them all through.
yeah, so I'm trying to think them through. So, if you get back to the whole boosting production, improving quality, reducing equipment downtime, IoT devices, I've seen it, especially in CPG. I think they're not unusual in this sense, but I think there's a lot of older technology as far as control systems, what have you. Being able to slap some IoT devices on machines and capture speeds and feeds and pressures and flows, uh, you know, all over a line, and do it relatively economically, right? Being able to capture that data that companies maybe have not seen, been exposed to, because they didn't have the capabilities. I think that's probably one of the big ones. IoT, cloud, edge computing, the whole 5G networks, where you get wireless. You don't have to wire up all these sensors I'm talking about. 5G networks, AI. As far as the virtual twins and stuff. I think that's probably some of the bigger technologies impacts.
We see rapid adoption across product lifecycle management of cloud, but in manufacturing, are we really seeing that? Well, you've got a mission critical system. Are we yet seeing cloud being adopted with those systems, or are we seeing it in other areas?
Excuse me.
And when do you see it fully being adopted, if ever?
Well, I think it will. It's again, this is all my opinion, what I've been telling you, right? So take that with a grain of salt. But it's been a slow and deliberate steps. Manufacturers are really risk adverse. They don't like risk. So it's and so the vendors that are supplying these solutions to them are following suit. It is a slow and deliberate steps, but they are moving forward, and they're trying to manage the risk. As I mentioned, they're risk adverse, managing risk. So they're coming up with hybrid architectures, to
Right.
where a lot of stuff is on premise, but some of the things that are maybe not as mission critical, uh,
So not real
is
time critical.
yeah, not real time
Yeah.
critical. They're putting that out on the cloud now, and then
Yeah.
you know eventually I see it. And you asked me about what the future is. I can't read the future, but my thoughts are is that it's going to be deliberate, and then eventually, uh, you know, as technology always does, technology comes up with a solution, right?
Yep.
Because there's a lot of manufacturers still, I would say, that that are that don't want to take on the risk of something happening and you shut down a line or whatever.
Yep.
Now, you mentioned a second ago the whole idea of hybrid technology, and so that and going into the future and the idea of, I guess, two things sort of helping to represent each other. What is the difference? We hear the buzzwords digital twin and virtual twin all the time. What is
Right.
really the difference between those and how you see those affecting things?
Right. So I say, unlike a virtual twin prototype that really focuses on one specific object, a virtual twin, lets you visualize and model and simulate what I would call an entire environment, maybe an entire line, an entire facility, an entire supply chain, right? And they uh, do it across, again, the full product life cycle. That's where I see the two. And plus, if I come to think about it, the with the virtual twin, you can do, to me, you can do past, present, and future simulations, where in what I would call a classic digital twin, you're able to do what's occurred, right? So it's either what's happening now in the present or what's happened in the past. You can't really go in. Again, my understanding, what I've seen is you can't go in and manipulate parameters and be able to run a simulation in the future.
Right. Got
And
it.
and it's only limited by somebody's imagination, the number of tests you can do. So again, I'm sure we'll talk about, other topics like new product introduction, but being able to simulate tests without having to do a physical test is just a tremendous advantage.
Got it. So forward-looking simulation. I understand. Okay.
Right.
David, in one of the previous shows, we talked about the need to model an entire plant, every piece of equipment, to the nth degree in order to create a digital twin or a virtual twin. Do we really need to go to that level? Can we do it conceptually, partially, etc.? What's really needed?
Well, I think, to me, it depends on what problem you're trying to solve, right?
Right.
So I think conceptually, practically speaking, if you're looking at a production line and you're having issues at a bottleneck within that production line, right? Every now and then something occurs that causes the line to go down, or waste material, raw material. You can go in and model just that section that you're looking at, right? That you're trying to solve an issue. Or you can then go out, if you see that you can figure out there, you want to go a little bit further upstream, you can add on, you can continue to make modifications to the model, right? And expand
Mm.
out the scope. So I don't think it's a matter of a necessity having to go to the nth degree. Again, it
Right.
depends on what you're trying to solve.
Yep. Yep.
So let's say that I woke up this morning and said, you know what, I want to create a virtual twin. How would I go about doing that?
Well, first you have to define the system, right? What you're trying to model. You have to understand the entity, what's required. What data needs to be there. Do you have data already? The data needs to be cleansed. Uh, there needs to be people within the organization that understand the operation, the physical processes, to be able to extrapolate that data into physical physical actions out on the shop. Okay, so that's the first thing, and then you have to create the twin. Obviously, you have to have a system level modeling tool, and then you have to and that can be, you can use again, like I said, existing data, manufacturing data. You can use engineering data, product data, CAD information, from design concepts, component libraries, all this stuff to be able to build the twin, right? And then, you can go in and, uh, you know, uh, do a model-based test and prove out the model, right? And typically, what you need is if you're trying to figure out where something is failing, right? It would be very beneficial to have historical data that you can look to see, on this day and this day and this day, the machine broke. It might have been different for different reasons, they think, but being able to identify that, those breaks, and being able to run that through the model and see if you come up with a similar result.
Got it. So where are you seeing today some good examples of a digital twin in operation, and what kind of impact is it having on the business?
Well, probably the first thing that comes to mind is predictive maintenance, predictive analytics, I'll call it. Also, predictive maintenance, to where people are, again, censoring up machines. They're trying to, again, it gets down to cost. They're trying to keep machines running as long as they can without having to take them down and do preventative maintenance, or, God forbid, unplanned maintenance, which is everybody's nightmare, right?
Yep.
So being able to go in, censor up the machines, you start monitoring machines, alert people when you start seeing drift within the machine's process. Again, speeds, feeds, temperatures, pressures, all this stuff. Okay, and then you have to be able, which it sounds silly, but you have to be able to schedule maintenance based upon those findings. And you may or may not have a lot of pushback from some of the, I call them the old manufacturing guys. They just wait till something breaks, or when somebody forces them because of preventative maintenance.
So you want to make sure that you are not just reacting, but planning ahead a bit, which I guess, what are the
Exactly.
elements really needed to deliver what are the elements needed to deliver predictive maintenance?
Okay. Yeah. So I can answer preventative maintenance a lot quicker, but predictive maintenance. So again, it gets back to the whole, predictive analytics. What I always say is you should start out with your worst case. So you find a machine that is having a lot of issues, right? And perhaps they have went in and determined what some of the root causes of some of the issues are.
Mm.
And then, as I said, some of the steps, you go in and you monitor the machine up, and you start and you build a model, and you start, looking at, what's happening within the machine. And uh, you can, uh, you can look at the quality and the timeliness of the data that you're capturing, and then having that real-time connection, you can actually start seeing. It's like anything within predictive analytics, real-time connection. You being able to uh, to see, what's might be occurring, and then scheduling, like I said earlier. So I don't know
Got
if I answered your question entirely, but it's, I would say work, select the worst case,
it. Yep.
prove it out, and then go from there.
Got it. Got it. Practically speaking, then, what are you seeing working best today with a digital twin, virtual twin? Where are you seeing it best in action?
So there is, as far as where it's working the best.
Mm-hmm.
Again, I would go back to predictive maintenance. Is probably one of the top ones, more of the common ones now. And then predictive analytics is really starting to catch on as far as manufacturing being able to figure out, you know, where it might take somebody days and weeks and months to figure out an issue, being able to go in and do, predictive analytics on a production line. That's, to me, is where probably the two best that I've been exposed to.
Yep. And any kind of impact on the NPI's processes?
Oh yeah, it's so you can talk about. I think I might have mentioned it briefly earlier. So new product introduction, you get into the whole virtual twin. So if you know anything about introducing new products, you have to test out the process and typically you'd have to take down a line at some point in time, which right now is not a good idea. It never has been, but it's even worse now because of all the supply chain issues. But being able to, as far as new product introduction and ramp up, being able to virtually test the process versus having to physically test the process is a tremendous benefit. You not again, not just in cost, because again, it's a double whammy on cost. You're taking down a machine or a line, so you're interrupting what you're making now, and you're having to burn the machine to do stuff that you may be doing in the future, versus doing something, doing something with a twin, and you can try all kind of different combinations, and it just and that goes to the focus that we talked about, with digital transformation. Is it's all about, it's about cost and innovation. So innovation, you can make different changes. Cost, speed to market. There's a whole benefit with using virtual twins and NPI. And then we've already talked about like I said, the predictive maintenance and process simulation optimization, being able to not just new product introduction, but also making process improvements to current products. And if you know anything about CPG, I mean, they're running on razor thin margins, right? So if you can save a couple of pennies on I say a large amount to CPG manufacturers.
Got it. Let me curveball you with one I always love to ask, and I've asked you this before, I know. If you had to choose between installing your MOM platform or your IIoT platform, I got to ask this because there's, what is it, 85% of organizations around the world do not have mass MOM installed. The XLs are working furiously away. Which one between the MOM platform and the IoT platform would you choose first, if you had to choose?
If I had to choose first, I would do the MES MOM. There's a lot more benefits, and but you're going to need, the IoT, because again, you're going to have to, collect data that's not currently being collected somewhere, right?
So
especially in CPG.
Hire the manager first and the doer second, yeah?
Yes.
Okay.
Well, I would say, the short answer, like I said, was MES MOM. So it's got a lot more different capabilities, and then IoT just enhances those capabilities as far as data capture and what.
Makes sense. I also agree, but anyway. Good, David. That is great. Hey, good to see you again. I'm glad you're feeling better, because you went down with the non-COVID, didn't you?
I did. I had non-COVID, whatever that's supposed to mean, Andrew. But that's what the doctor called it, and I tell you what, for the last few weeks, it's the worst I felt, I think, in my life. And I've been here on the earth a long time, but
That sounds like
it was
COVID,
rough.
COVID then.
It was COVID square.
Yeah, you got the
You
COVID,
bet.
COVID, non-COVID, COVID, non-COVID, COVID coming.
Exactly. Yeah. But I'm actually, thank you for asking. I'm actually feeling better now, if you can't tell.
Yep. The cough is gone. Good to hear.
Yeah.
We appreciate you joining us and sharing some of, I mean, there's obviously a vast amount of knowledge hidden in your head there that was just peeking out as we're talking. And yeah, I think it's definitely a lot more to dive into too.
Thank you. Thank you,
Thanks,
guys.
David.
Talk to you
Appreciate it.
soon.
Cool. Thanks.
Bye.
Thanks, everyone. Appreciate you sticking with us, watching through this. That is great. Bottom line is, it's a massive amount of data in manufacturing. It's not necessarily collecting it. It's what you do with it. It's how you manage it. It's how you integrate it across the enterprise as well. But above all else, do something, take action, and get on with it.
Yeah, thanks for joining us, everybody. We will see you next week, and that's a bye from me.
And it's goodbye from him. See you next week.